Okay, in this class I just want to look at using the multiplication rule and the condition rule again in a couple of different contexts. So what's the probability of getting my first 6 on my third roll of the die? So I roll this die 3 times. What's the probability of getting a 6 for the first time on the third roll of the die? So it's the probability of getting a non-6, and then another non-6, and then a 6. And my multiplication rule will say, well, that's the probability of getting a non-6 times the probability of getting a non-6. Given that we've gotten a non-6 already, times the probability of getting a 6. Given that at this stage we've got 2 non-6s. But, you know, what happens on one roll of a die does not affect what happens on the next roll of a die. So these kind of things are independent of each other. And we'll be talking more in later classes about independent and dependent events. The probability of getting a non-6 is 5/6. The probability of getting a non-6 on your second roll is still 5/6, because what happens on the first roll has no bearing on what happens in the second roll. The probability of getting a 6 on the third roll is 1/6. Multiplication, that's 25 over 260. That's really straightforward. Looking at a slightly more complicated example. Suppose an experiment consists of the following 2 tasks. Task 1 is to roll the die. Task 2 is to spin one of the spinners. And the rule is this: if the roll number on the die is odd, we spin the first spinner. So odd number on the first one, we get first spinner. And if the number on the die is even, well, then we spin the second spinner. Your total is the sum of the scores on the die and the spinner. We want to find the probability that you get a total of 9, given that you got an even number on the die. So I'm going to let n be the event I get a total of 9, and e being the event I get an even on the die. If I think about this, I want to find the probability you get a total of 9, given that you got an even number on the die. Well, that's the probability that you get a total of 9, probability of n, total of 9, given, vertical line, that you got an even number on the die. And that's, my conditional rule, which is the probability of a total of 9 and an even on the die, divided by the probability of an even on the die. So what's the probability of these things? Well, the one on the bottom here is very easy to calculate. The probability that I get an even number when I roll a die, well, there's 3 even numbers, there's 6 sides, so it's a 3 and 6 or 1 and 2 chance. Of course, the probability of rolling an odd is also 1 and 2, assuming it's a fair die. Getting a 9 and an even is slightly more complicated. Getting a 9 and an even. And if you think about, all the possible outcomes from this experiment, we've got a dice and a spinner. On your die, you could have 1, 2, 3, 4, 5, and 6. And with each of those outcomes you will spin a spinner that has 3 possible outcomes. So if you roll a 1, you could then spin spinner 1, because 1 is an odd number, and you would get 2, 5, or 8. If you roll a number 3, which is odd, well, then you'd be spinning 1, you get 2, 5, or 8. And again, if you roll a 5, which is an odd number, you'd be spinner 1. Possible outcomes are 2, 5, and 8. If you roll a 2, or 4, or 6, you'll be spinning spinner 2, giving you a 3, 4, or 7. And that's kind of, how we could kind of get a picture of this thing. If I was to list all the different outcomes, the first outcome here would be a 1 on the die and a 2 on spinner 1. The second outcome would be a 1 on the die and a 5 on spinner 1. The third outcome would be a 1 on the die and an 8 on spinner 1. The next outcome would be a 3 on the die and a 2 on spinner 1. Okay, how many outcomes would there be altogether? Well, 3, 6, 9, 12, 15, 18. There's 18 possible outcomes in this experiment. 18 possible outcomes in this experiment. The number of ways to complete task 1 is 6. The number of ways to complete task 2 is 3. 6 by 3, 18. So, I want to find a couple of things in here. One thing that's nice and easy is the number below the line. What's the probability that I roll an even? Well, we know that is a half. So I'm going to put a half down below the line. We need to know how to divide fractions here. On the top, I'm looking at the probability of getting a 9 and an even. One thing to note about the thing on the top, we know there's 18 possible outcomes. So it's going to be something over 18. So in how many of these outcomes do we get a 9 and an even? Well, we get a 9 with a 1 and 8, but that's not an even, so we're only looking at the evens. 2, 7. 2 on the die, 7 on the spinner, that'll give me a total of 9. 6, 3. 6 on the die, 3 on the spinner. Spinner 2, that'll give me a total of 9, and there are no other ones. 4 won't combine with any of these things. We can get 4 and 3, 4 and 4, 4 and 7. None of those will give me a total score of 9. So there's only a 2 in 18 chance, which is a 1 in 9. So I have as 1 in 9 divided by 1.5. Keep flip change. 1/9 times 2. That's 2/9. So there's a 2 in 9 chance of getting a total score of 9, given that the outcome on the die was even. Okay, so that's a conditional probability. You have to know your formula. The probability of B given A is the probability of A intersection B divided by the probability of A. Learn it by heart. Gotta know it. Let's look at the same experiment with a slightly different question. Here I'm asked to roll the die and spin a spinner. If the number in the die is odd, all the same stuff. Your total is the sum of your scores. Find the probability that you get an even number in the die and you get a total of 9. So here we're looking for the probability of getting an even number on the die and, not given, and a total of 9. And we know that's the probability of an even number on the die multiplied by the probability of getting a 9, given that we got an even number on the die. Okay? And in fact, I think I was calling that event n. So let me just change that from 9 to n. So given probability get an even number and then a total score of 9, and that's going to be equal to the probability of an even number times the probability of a total of 9 given an even number. So the probability of getting an even number is 1/2. The probability of getting a total score of 9 given an even number, well, actually, I'm pretty sure that's just what we found. The probability of getting a total score of 9 given that it's even is 2/9. So it's 1/2 times 2 over 9. Cancellation of the 2's. There's a 1 in 9 chance. So 1 out of every, we would expect on average 1 out of every 9 times we completed this experiment, we'd get an even number on the die and a total score of 9. Okay, so that's your multiplication rule and your conditional rule. Remember, your multiplication rule says the probability of A and B, well, that's equal to the probability of A multiplied by the probability of B occurring given that A has already occurred. Okay, so practice, practice, practice. 5.6, you should be able to complete everything in there now.